I have unmuted. All right, so let me get started now. So last time we were talking about, system of linear equations. Uh, are you able to see it, the full screen?
Yes, yes.
All right. So let me just bring it down. Ah, okay. So why do we need linear system of equations? So uh, see, sometimes we need to, we want that the variables should be they are linear. For example, take here, just see this example. Here you have price of a house which is y, and it is dependent on the size of the house and the number of the rooms. So the relationship is linear. Okay, it's linear. We are assuming it's linear. Okay, in that case, we have linear system of equations. Suppose the size of the house is this, number of rooms is this, and the price is this. Now we have to find how these variables are, how x1 and x2 they are affecting the price, how the number of rooms and how the size of the house it is affecting the price. So we want to learn the relationship, like what is the relationship between y, which is the price of the house, and x1 and x2. Okay, so how do we determine this relationship? So we want to find what is your W1 and W2. Okay, what are the weights given to, or you can say, what is the importance of X1? X1 is the size of the house. What is the importance of X? If the weights are higher, you will say, okay, higher the importance of, the size of the house. If W2 is higher, you will say, okay, higher is the importance of the number of. So basically, if you have first, so this is the first house. Like you have suppose three data points. Three data points. This is for house one, this is for house two, this is for house three. Okay. So you will say, okay, W1 into 1 plus W2 into 1 plus B. B is some bias. Okay, is equal to 6. Okay, then you have 2 into W1 plus 1 into W2 plus B is equal to 9. Okay, then you have W1 into 1 plus 2 into W2 is equal to 8 plus B is equal. So you have, so this problem you can solve using linear regression as well. But since the number of weights are very less, just 2 weights. So and you are given the number of samples also, 3 samples. So this is like you have 3 equations, 3 unknowns. So you can very well solve it using the system of linear equations. Okay. So your target is to find what is W1, W2, and B. Okay, and the system of linear equation will help you in getting these values. Okay, so we saw that in the last class. Okay, now I told you how this system is, um, inconsistent. Now I'll do it whatever using the knowledge that you have learned so far, that is REF. Okay, so first we have to write it in the form of augmented matrix, because this is of the form AX is equal to B. So you just collect the coefficients. 1, 1, 1. See, 1, 1, 1. This is your first row. Then 1 minus 1, 2. This is your second row. And for 2, there is no coefficient of x2, so 2, 0, 3. So basically, this is like A if you multiply by x. If you multiply this A by x1 vector. 1, 1, 1. Then 1 minus 1, 2. And then 2, 0, 3. So what will you get if you multiply x1 plus x1 into x1 plus 1 into x2 plus 1 into x3 is equal to b1, b2, b3. So b1, b2, b3 is this 3. This is your 3. This is your 2, and this is your 1. I'll just write it again. So you can multiply like this. 1 into x1 plus 1 into x2 plus 1 into x3 is equal to 3. So that is your first equation. Next equation is 1 into x1 minus 1 into x2 plus 2 into x3 is equal to 2. Then 2 into x1 plus 0 into x2 plus, so you are doing just matrix multiplication. That's it. Now you just take, this is your A, this is your B. B is your right hand side. So just write it as an augmented matrix. Augmented means you just append A with B. This is your A. Okay. Yes, mute if any difficulty till this point.
No.
No, no, ma'am.
Okay. Now again, the next task is very easy. Convert this whole into REF. That is row echelon form. So you just pivot means the leading entry. So what is your leading entry? This. So convert all the entries below leading entry to 0. So first task is make it 0. Make this as 0. How will you make it? So R2 will be R2 minus 2R1. Okay. And R2 will be R2 minus R1. So 1 minus 1 is 0. Minus 1 is minus 2. 2 minus 1 is 1. 2 minus 3 is minus 1. It is recorded. It is getting recorded now.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. It is
Yes,
getting
yes.
Okay. Because okay, thanks for confirming. Okay. Should I make it full slide? Okay. Now the task is, now you tell me. See, 2 minus, now next is, you have to make this entry as 0. So you'll say, okay, R3 is R3 minus 2R1.
Ma'am, what about that 3, 2, 1? Okay, writing.
This will also get modified now. See, this is row 2, now row 2. This is row 3. So row 2
Okay,
we have applied row 2.
So now this augmented matrix will be a 3 into 4 matrix, is it?
3 rows, 4 columns. Correct. You are right.
Okay.
Okay. So whatever operations that you are doing it here, you have to do it same operation here also. All right. So you have got this. Now what is your next task? Tell me.
We have to make the third row minus 2 to
Sir.
0.
Yeah, second row minus 2 to 0.
No, second row not to, no. Second
We
row
have
should
to
not.
make R3 equal to R3 minus R2.
Okay. So now you say this is the second, this is the pivot element or leading element of row 2. Okay, it is present in column 2. So you have to make all the entries below this leading entry to below this pivot to 0. So make it 0. How will you make it? So you have to take R3 is R3 minus R2. Okay, so what will you get? Minus 2 minus 2, 0. 1 minus 1, 0. Then minus 5 plus 1, minus 4. Now what is the problem here? I hope you got it. Are you there with me till this point?
Yeah.
Yes,
So whatever
Yes, ma'am.
row subtraction or multiplication we are doing, we just
Your
have
voice
to do
is
that.
feeble. No, it's fine. Tell me.
Okay, so we just have to do the same calculation for the outputs, right? That 3, 2, 1. So the row operation, whatever we are doing, we have to do it for the output exactly the same way. That's what we are saying.
Exactly. So it's treated like a metric. Like this.
Correct.
Okay. Now, important observation is this on the left hand side you are getting 0, but on the right hand side is minus 4. So basically, what you have got is, now if you just, this is your A, mu A, this is your mu. Okay. Now if you put it in the form of Ax is equal to B, what will you get? So x1 plus x2, because this you have to multiply with x1, x2, x3 now. So x1 plus x2 plus x3 is equal to 3. Then next with
Minus
Because
2x1 minus
because it's
2x2.
like this now. 1
Hmm.
1 1 0 minus 2 1 0 0 0 x1 x2 x3 is
Hmm.
equal to p1 this 3 minus 1 minus 4. Now what have you got? X1 you multiply this, so you got x1 plus x2 plus
Plus
x3 is
x2.
equal to 3. Then minus 2x2 plus x3 is equal to minus 1, and 0x1 plus 0x2 plus 0x3 is equal to minus 4. Do you think it's right? This equation is consistent? Like, don't you think something strange about this?
Yes.
Yeah,
So
this
what
is
we
Yes.
have got?
impossible to get, right? So we
0 cannot
cannot
be
have.
equal to minus 4.
Yes, 0 cannot be equal to minus 4. This is this is impossible. So what you conclude? Conclusion is this system of equation is high, like it is inconsistent. You cannot have such a system of equations.
So that means we
Okay.
cannot have a mathematical solution for this, a stable mathematical solution for this. When we do regression, or let's say
No,
using
no.
this.
Regression also, you cannot find weights also there
Correct.
in
Yeah.
such case, right? Okay.
Yeah.
Now the thing is, why here you're getting inconsistent solution. The idea what I'm trying to convey now is, please pay attention, I request. So this is your A, this is your B. This is augmented matrix. Now I told you also about how to find the rank. So what is the rank of augmented matrix?
1,
What is the
1,
2.
I,
2. 2.
2,
2.
2.
2.
why we say 1? Okay,
no,
for
Baba,
the
not
second
2.
one.
It is 3 now.
3.
This
Minus
Augmented
way
1
it
is
is
there.
3.
For which one we are
It
saying?
is 3.
Okay.
What is
Mhm.
rank? Rank is the
Non-zero. Non-zero
number of
rows.
correct. You already know it. So what is the number of non-zero rows here?
3.
3.
3.
Okay.
What
A
about
and B.
rank A? What is rank A?
2.
2.
2.
2. So whenever you have such kind of situation, whenever rank A is not equal to the rank of augmented matrix,
Impossible. Illogical.
then you have inconsistent. Please make it note in your notebook. Okay?
Yeah. Madam, I have a question here. How did we get that first 3 equations on the left side? Given the system, maybe I joined, I was not paying attention.
What are you saying? How did
The
we
first
get?
the first 3
That
equations
is
on
the
the left
problem
side.
statement.
So it is
That's the
that's the
question.
Which
okay,
step
that's
you're talking about? Step one?
The equations, ma'am.
the
First
equations,
one.
the very question, before the first step 1, the equations are given. That's the problem statement, or did we get it
x1
from
plus
previous
x2
slide?
plus
These are
x3.
not, these are given only. From that
Okay.
you have to collect these coefficients now. 1.
Okay.
I told you now this is ax is equal to b. Now this is written as, if you multiply a with this x1, x2, x3, you will get these equations.
Got it.
Okay?
Yeah.
Ma'am, one question. So here the question was whether these linear equations are consistent or not. That was the question.
No, question was what are x1, x2, x3? How these are unknowns. What are values of x1, x2? Solve. It was given. Question was to solve. Solve this system of equations. Solve means find the values of x1, x2, x3 that satisfy these equations.
Yeah.
Okay.
So, madam,
yeah.
so the idea here is to just understand whether a given linear system is manageable to find the correct outputs. If the data is unstable, then we cannot find. That's what we are trying to just say.
Yeah,
Or
data is, it is inconsistent. You say this
Okay.
this system of equations cannot be satisfied. Like this is inconsistent. You say.
so what if the rank is matching? Then we will also just say and conclude there, or we go further.
No. I'll show you. We have in next example. If rank
Ma'am,
is
can you?
equal to,
Yeah, ma'am.
Okay.
I think only 3 possibilities, right? No solutions, infinitely
Yeah,
many
yeah, yeah.
solutions as unique solution.
yeah. So here you have no solution kind of scenario because Because tell me, rank of A is not equal to rank of A augmented B. Okay, is it fine?
Ma'am, can we just go back to the previous slide, ma'am?
Previous slide, nothing was there,
Yeah,
only
this,
system
yeah.
of equation.
Yes, ma'am, I suppose this equation only we are taking there.
Yes, only this equation. Earlier,
We are
I
taking
just
in the
told you.
next one. So
Yeah.
my question is, this is also a set of simultaneous equations, what we have learned in our primary classes. So using that also we can solve it, right? That value of x1, x2, x3, because we have three equations and we have three unknowns.
Yeah. But I want to link it to the rank concept. I wanted to link it to REF concept. Okay.
Okay.
So whatever
Okay.
method that those methods are valid, but since in MFML, you'll be joining, your session will be starting. So I'm preparing you for that. I'm linking all the concepts like rank, REF. Okay, then system, how the rank is influencing, the solution, like how rank is determining whether we can find the solution to the system of linear equations or not. Is that okay?
Yes, ma'am. Got it.
Okay, now moving ahead. Now we have new example. See, this is the given system of equations. Okay, this is my augmented matrix. This is my A, this is your B. This is your B, 3, 2, 2. These are coefficients. So again, I have to do REF form, convert it into REF form. Step 1, I'm done. Augmented matrix. Step 1 is just construction of augmented matrix.
Doubt.
Yes.
And in previous example where we had three equations, in the third equation, the 2x1 plus 3x3 is equal to 5 was there. So if that would have been the scenario here, then rank of A would have been equal to rank of A augmented B. So what would be the inference in that scenario?
Yeah, that's what I'm trying to say now. Like in this, we are modifying this example little bit, and then we will arrive at, okay, the solution is existing. Okay, that's what you are saying.
No, like for infinite solutions, would the scenario be that
I'll come to that. We'll go slowly. Okay, just okay. Thank you. Okay, now again, the next step is REF. REF, first pivot means leading element. First leading element. That is considering the first row. So that means, so you have to convert all the elements below this entry to 0. This is already 0. Okay, fine. Now you have to convert it to 0. So what operation you will perform? You will perform R2 is R2 minus R1. So 1 minus 1 is 0. Minus 1 is minus 2. 2 minus 1 is 1. 2 minus 3 is minus 1. Okay, sorted. This row you need not touch because this is already 0. All right. So okay, now step two we are done. Now next step is you have to convert. Now this is the pivot element or the leading element of the second row. Now next task is you have to convert this to 0. So what operation you will apply? So you will say, okay, 2R3. R3 is 2R3 plus R2.
Now I can do R3 minus R1.
No, I told you now, if you do R3 minus R1, what will happen? This will turn to 0, non-zero element. See here.
Okay. Yeah. Got it. Sorry. Yes.
No, don't say sorry. It's fine. Okay. So that's why if you want to convert this element to 0, this is beyond the leading element of the second row. So that's why I have to make use of the second row only. We have to be very systematic. Okay. Now you are done. So this is how will you convert this to 0? So you'll say, okay, apply this operation. R3 is 2R3 plus R2. So this is 2 plus 1, 3. Then 2 into 2, 4 minus 1 is 3. Okay. Now you are done. So now Now this is of the form mu A, this is of the form mu B. Now the thing is you have to make it, now you have to convert it into the equations. How will you do? So x1 plus x2, so write it in the form of this AB, so write it in the form of AX is equal to B. That means multiply this A with the X column. Okay, so what you get? X1 plus X2 plus X3 is 3. But we'll start from the bottom. We'll start from the bottom. So what is this? 3x3 is equal to 3 because this is the third column. Third column is for x3, right? 3x3 is 3.
So we can
this
find x3 and substitute in the first row.
So x3 is equal to 1 you get. So this is the back substitution. Now you are substituting back because you are starting from downwards. So now substitute this value of x3 in this equation. What is this equation? Minus 2x2 because this is the x2 column x3. Minus 2x2 plus x3 is equal to minus 1. Substitute x3 here. What will you get? X3 is 1. You have just calculated. X3 is 1. 1, 1. Okay, this gets here. So 2 minus 2 x2 is minus 2. So x2 is 1. All right. Now substitute x2 as 1 and x3 as 1 in this, the first equation. So what is this? X1 plus x2 plus x3 is 3. Substitute x2 1, x3 1. You get this. So x1 is 1. Now here you have only one solution, one unique. X1 will not, x1 you cannot give any other value to x1. Okay. X2 also there is only 1 and 1 value. Okay, now you say system has unique solution, but the point to be noted why it has unique solution. Why? So you look at, see, this is the final REF form. Okay,
Yeah.
just look at what is the rank.
The rank is matching. So
yes, rank of AB, A augmented B. This is augmented B is 3. 3 because there are 3 non-zero rows. Okay, this is 3. What about rank of A? Rank of A is this. You will consider only this matrix. So rank of A again, you have 3 non-zero rows, so which is again 3. So both are equal. Both are equal, which is equal to the number of variables. Number of variables is 3. So if rank of augmented matrix is same as the rank of matrix A, and if it is equal to the number of variables, then you have a unique solution. Please make a point of it in your copy. See, I suggest you make one copy for maths. Okay, so whatever.
Ma'am, can you repeat this part? Ma'am, can you repeat this part? Rank of augmented B, A and B is equal to rank of A. This part. Can you just repeat this part?
Yeah, sure. I'm saying if rank of A is equal to rank of augmented matrix, which is equal to number of variables. Number of variables are 3, x1, x2, x3. Then you say system has unique solution.
Ma'am, I was there with you till x1 equal to 1, x2 equal to 1, and x3 equal to 1. After that, can you repeat that part? Yeah, means we got the solution that x1, x2, x3 all equal to 1. After that?
Yeah, ma'am, that rank is not
After
clear.
that-
Can you?
After that, we have to analyze why we are getting unique solution. So I'm trying to tell you what's the reason of getting unique solution. So this is the final REF matrix. Do you agree with me? This is the final REF matrix.
Yes, ma'am. Yes, ma'am.
So this is your A, this is your B, and from the REF matrix you can find the rank. Yes.
Yes.
This is your A. What is the rank of A? Tell me.
3. Rank of A is 3.
Okay. Now what is the rank of augmented matrix? Augmented matrix is this. What is the number of non-zero rows?
3.
Okay. We only consider rows, right, ma'am?
Yes.
For rank, we only consider rows.
Yes, number of non-zero rows in REF.
Okay, yeah. 3.
3. So both are equal. Now this is also equal to the number of variables.
Yes, ma'am.
Number of variables are how many? 3, right?
Three,
X1,
three,
X2,
three.
X3.
Yeah, 3.
So that's why we are getting unique solution. If the rank of the matrix A is equal to the rank of augmented matrix, which is further equal to the number of variables, okay, only then we'll say. If n is suppose, in general, you can write like this. If n is a number of variable and if the rank of matrix A is equal to the rank of augmented matrix, which is equal to n number of variables, then you say system will always have unique solution. Is it
So,
okay?
Yeah, so ma'am,
Yes, ma'am.
this
Got it.
is the like okay, this is a mandate to have these values as same, right? To have a unique solution, right?
What? Sorry.
Am I audible?
Yes,
Yeah,
yes.
you are audible. Tell me.
Yeah, so what you mentioned, like okay, number, yeah, whatever the rank values is coming and like okay, whatever number of the variables are there, right? If that match, then only we will be having the unique solution, right?
Yes, perfect.
Okay,
You got
yeah.
it. You already
One more.
know so many things. Okay, now let's
Thanks.
come to new
Ma'am,
system
unique
of.
solutions.
Does, ma'am, does unique
Yes.
solution mean only one possible solution or multiple unique solutions?
Correct.
No, only one and one solution. Only one. You cannot have any other solution. You cannot have any solution other than this 1, 1, 1. That means x1 cannot take any other value, x2 cannot take any value other than 1, x3 cannot take any value other than 1. So this is the unique
Okay.
one
So,
and only one.
ma'am, using the after REF operation, using the rank, we can get the values. There is no need of calculation x1, x2, x3. If it is like a
No,
rank of
I did not say that. I just commented on, why are you getting unique solution? You have
okay,
to solve. You have to
okay.
solve for this. Otherwise, how will you find x1, x2, x3? I was just telling you the concept, why you got unique solution for this. The concept is the rank of augmented matrix is same as rank of A, which is equal to the number of variables equal to 3. Okay, so that's the reason you are getting unique solution.
Yeah,
I
but
hope
madam,
it's fine.
practically all the values will not match, right? In a practical data set, because we always find the Euclidean distance between the actual value and what we are predicting, and we somehow try to
Yes,
minimize the loss, right? So
yeah, correct. So then if you have, very big, like so many variables, 1,000 variables or maybe
yeah,
10,000, there you'll use linear regression basically.
yeah,
You'll not use system of equations.
correct. So I'm just trying to
Because
see how we practically use uh, this substitution that we are doing here.
see, if you have very small data set and if you know that data set is not noisy, like then
Yeah,
like you have small number of variables, then you can use, this linear system. Otherwise, you use linear regression and all.
correct. Yeah, that's what I'm just trying to understand. Yeah.
I have a question
Okay.
here. Uh, I have understood what you have just said, madam, but I have a question here. If rank of A is greater than rank of B, can we still have a solution?
Rank of A is greater than rank of B. But no. Rank of B is always, you are saying B is this, right? No. Then you cannot have solution. I told you if rank of A is not equal to rank of the augmented matrix, you cannot have solution.
Both
So what
Solution
if
ranks
will
will be
not
the
same,
exist.
right?
what if the equation says 0? So if you go back to that equations, what if it says equal to 0? Won't we have that
Then,
kind of problem? Let's say in the third line, in the third equation, it says equal to 1, or any of this equation, 2x1 plus 3x3 equals 1. What if it equals to 0? That should be a proper
okay, you
equation,
are
right?
saying this here it should be 0.
Yeah. What if that? No. let's go to the next one where we add the solution. This is a no solution scenario, right? If you go to the next slide.
Okay, I'm going.
Yeah, he
Yeah,
mean to
here,
say like, okay, yeah,
what
whatever
if
the
that
equation.
last on the last column, it says 3 minus 1, 3, right? That is where we
Acha,
solve the
zero.
equation.
Okay, okay,
What if
got
we
it,
put a
got it.
0 there? That should still give us a 0. Sorry, so give a solution, because that's a proper
Okay,
equation.
okay, I got your point. I got your point. I'll just tell you. So you are saying, okay. You are saying this is 0, right?
Yeah, that is 0. So rank of B is not equal to.
No, rank of B. No. I'm not talking about rank of B. I'm talking
Yeah.
of rank. So it's still, see, this is non-zero row. This is non-zero row. This is non-zero row. So rank of
Okay.
A augmented A, it is still 3 now.
Yeah, okay.
It is still 3. If you will have solution, why not you'll have solution? You'll still have.
Right. Yeah, we will have it, yes.
If you permit, can I move forward?
Ma'am, I have one doubt. If you're able to hear me, can you iterate once about the infinite solutions and no solution scenario?
Infinite I'm not reached. I only talked about unique. I'll talk about it. Infinite.
Okay. Sure.
Okay, now we have this system of equations.
Ma'am, so whenever the rank of augmented and rank of A is equal, I mean the x1, x2, x3 is always 1. I mean that is what you said. That can be different, right? This is just for this solution.
It can be different. X1 is 1. It can happen, and if you have system of equations which has x1 is 1, x2 is 40, x3.
Okay. Got it.
Okay. Now let's go to this. Now suppose the system of equations is this. Okay. Again, we'll put it in augmented form. A, you'll take the coefficients 1, 1, 1, 1, 1, 1, 1 minus 1, 2, 1 minus 1, 2, 2, 3. There's no coefficient of x2, so this is 0. Then 3. Then this is your B. 3, 2, 5. Okay. Now, again, we have to convert it into REA form. So this is the pivot variable. That's a which is same as leading element of row 1. Then convert this entry to 0, this entry to 0. Okay, R1 minus 1, R2 is R2 minus R1. 1 minus 1 is 0. Minus 1 minus 1 minus 2. 2 minus 1, 1. 2 minus 3 minus 1. Okay, now how will you convert this to 0? So you will say, okay, R3 is R3 minus 2R1, right? So get 2 minus 2, 0. 0 minus 2 is minus 2. 3 minus 2, 1. 5 minus 3 into 2 is minus 1. Oh, all right. We are sorted for this column. Now you go to the second row. Second row, this is the pivot element because this is the first leading element of row 2. Now your task is to convert the entry below this leading element to 0. This entry, how will you convert? So you say R3 is R3 minus R2. So you have done. Now you go to this step. Okay. Now R3 is R3 minus R2. So minus 2 is minus 2 plus 2 0. 1 minus 1 0. Minus 1 plus 1 0. Now see, the last row is 0. Last row is gone. So you say 0 equal to 0. There is no inconsistency. 0 equal to 0. Now you go to row 2. Row 2, what will you get? Minus 2x2 plus x3 is equal to minus 1. Now, point to be noted here is, what are your free variables? Free variable is corresponding to, okay. So you will say, okay, x2 is t. Okay.
Ma'am,
so you
did not get you. Yeah, you are highlighting that row. You are saying.
Yeah. Hello.
Yes.
Are you there?
Yes, ma'am. X1, XL from the last row, we are not getting any result. So you are telling about row 2. Carry on.
Should I carry on?
Yes,
We are
ma'am.
looking at
Yes.
last row is 0. So 0 is equal to 0, you will not get any solution. So now you have to solve for, your target is to solve for x1, x2, x3. Okay. Now I want you to pay attention here. See, this is the pivot element of column 1, right? This is corresponding to x1. Okay. Pivot element means the first, the leading element, leading entry. This is a pivot. Okay, so you call this as column also as a pivot column. Now this element is a leading element of row 2. Okay, and this is also pivot. Like you can call this column also as a pivot column. Okay, is that okay?
Yes, ma'am.
Got it? Now this x3, this is the column third. It does not contain any leading element, right?
Yes.
Right or not? So that means your pivot variables are x1 and x2, and x3 is just ignore this equal. And x3 is your free variable. X3 is your free variable. Okay. Is that okay? X3 is your free variable. Here it is written wrong. X3 is equal to, X3 is your free variable. Give it some value as t. T. See, first, because this is the situation where you have rank A is equal to rank of B, but it is equal to, it is less than the number of variables, right? Because it is 2. You can see the rank of A is 2, rank A is this, which is number of non-zero rows is 2. And if you talk about rank of augmented matrix, again, rank of augmented matrix is you have only 2 non-zero rows in augmented matrix. So which is also 2. So see, rank of A is same as augmented matrix, rank of augmented matrix. And it is equal to, like, it is less than the number of variables, 3, because it is 2. This is 2. Okay, so in this case, when ranks are equal, rank of both A and augmented matrix are equal, but they're less, the rank is less than the number of variables. In that case, you will have infinite solutions. Now I'll tell you how infinite solutions.
Ma'am,
Okay.
Sorry, ma'am. Actually,
Ma'am, why
rank
you
of
are telling us free variable? Why you are saying, why you are terming it as a free variable?
No. See, free variables are those variables corresponding because columns or columns associated with them, they are they do not contain any leading entry. Okay, they do not contain any leading element. All right. So that's why
Ma'am,
you
can
are
you go
calling
back
it
to
as
that
a
slide?
free.
Why you are saying that? Why you are saying that?
Why we are, because you can give any value to that variable.
Okay.
This is how it works. Because
So
that's why
you are saying x2 as a free variable, x2.
No, this is wrong. This is wrong. You will go to this. Till this slide, it's fine. Till this, it is fine.
Okay.
Sorry, ma'am.
Okay, just remember these equations. So what you get? You have two equations. So what you have, -2. So first equation is x1 plus x2 plus x3 is equal to 3. Next you have -2x2 plus x3 is equal to -1. Okay?
Yes.
Is that
Yes.
okay? Now
Yes.
you
Yes.
see, now there are two equations, but number of unknowns are 3. So one variable has to be given some freedom. And which variable is that? The free variable corresponding to which the column. So this is the column corresponding to x3. It does not have a leading entry. So that's why you are giving it a free name. That means you have to assign some value to x3, some value. Then only you can find x1 and x2. Okay.
So that means if the column 3 has all valid values, then we can somehow find the x3. Right now, that's not possible. with this matrix.
Yes. Yeah, it's not possible to have unique solution for all.
Yeah.
Okay, the solution will exist definitely because the rank of A is equal to rank of augmented matrix. Rank is, oh sorry.
Ma'am, rank of A, it's 3, no? And rank of augmented matrix might be 2, no?
No, both are 2 now. See this.
Non-zero.
Rank of A means like initial thing, no? That is the augmented matrix, I think, no? The A of X is equals to B. So rank of A means 3 should be, no?
Why 3? This is your A now. REF form you look into REF. This is your REF.
R3 is 0.
This is your A. This is your A. So only 2 non-zero rows, right? And augmented matrix also 2 non-zero rows.
Yeah.
That okay.
Yeah, but
Ma'am.
madam, one more question. So if you have a bigger matrix, sometimes you can find, let's say, x5 is equal to some value, but that does not mean we can apply it in the upcoming the before rows, and we can find the other coefficients, right? So you can still end up in a situation where you can say like x1, x2 plus x3 values you might have. You will still not be able to find x1 and x2 because you still have infinite solution because of the bigger matrix. That could be still possible, right?
No, you can find the C if you have a little bigger matrix, okay? If the ranks are matching, that means rank of A same as rank of augmented matrix, but it is less than the number of variables, you will have infinite solution in that case.
No. What I'm meant to say is now we are saying we cannot find because -2 x2 plus x3 we cannot find because we at least need to know x2 or x3. So if you have a bigger matrix, correct? So for let's say x1 to x5, you only know x5, but you x1 to x4 you still don't know. In that case also it becomes an infinite.
You have to solve now. You have to solve for system of equations.
Yeah,
ma'am, I have a
I'll
question.
tell you. Just wait for a while. I'll solve this. Okay? Is it okay?
Ma'am,
Yeah,
one
go
quick
ahead.
question. One quick question.
Now,
Why you mentioned the last third column as x3? Why not call it x1 or x2? The 110 column vector.
That is the third column, right? Which is
okay, I'll
So
tell
are
you
we?
first that. Okay.
Yeah.
I
it has a
started
leading
with
into.
class. Okay, fine. I'll first handle this down. See, what is this? This is AX is equal to B. So if you say, okay, in color is purple, suppose. 1, 1, 1. 1 minus 1, 2. 2, 0, 3. X1, X2, X3 is equal to. Okay, do one thing. Let's do one thing because this slide is already so much. You just remember this and tell me the values. Okay? Tell me the values.
1, 1, 1,
1, 1, 1,
3, the
3,
augmented. No, on the augmented side.
3. Then, oh
Second row
sorry, I
is
did
1
not
minus
do
1, 2.
1.
Second row is 1 minus 1, 2.
Then
And then 2, 0, 3.
2, 0, 3. Okay. This is equal to B. What was B?
3, 2, 5.
Now you ask, now who asked this question? Why is not x3? See, when you multiply, this is x. x1 into 1 plus x2 into 1. See this. Now you take the dot. This is matrix multiplication. x1 plus x2 plus x3 is equal to 3.
3.
x1 minus x2 plus 2x3 is what is it? 2. This is matrix multiplication. Now you cannot associate. So the third column is corresponding to x3 only now. Because third column only is getting multiplied with x3. And then 2x1 plus 0x2 plus 3x3. See, 2x1 plus 0x2 plus 3x3 is equal to 5. So, see, third column coefficients are 1, 2, 3. And 1, 2, 3. Are you, did you get? Hello.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
okay.
Yeah, that's clear, ma'am.
Okay. Okay, now just ignore all this.
Ma'am, but
Okay.
I was just saying one thing. How it is mentioned here, that is also not wrong, ma'am, because they are taking x2 equal to t, and so for they are mentioning that x1 equal to a form of t, x2 equal to t, and x3 equal to also. So if we take
Okay,
t,
okay. So first let
any,
me solve this now. First, now this is the pivot column because it contains the leading entry of row 1.
no,
This
ma'am,
all,
I want to understand what is wrong here, because from
what
the
is wrong where?
interpretation, yeah,
Where?
interpretation. No, here you are saying that interpretation, this row 2, row 1, that is wrong. It is not. It doesn't seem to be wrong, ma'am. That's what my question is, because they are
What is
substituting.
wrong? I'm not understanding what is wrong here. What are you like? What do you want to say? That that column I'm mapping is wrong.
No, ma'am. You said that x3 is a free variable, but in this PPT it is x2 is t. So he is saying it is also right. It is not wrong.
Yeah, that's what I'm
Why
saying. That
x3 should be treated as a free variable?
yeah, here x2 equal to t. That is, they are just substituting. That's all. If we don't treat it as, yeah, they are substituting x2 equal to t. So from the second equation, we are getting a value of x3, and from the first equation, we are also getting a value of x1, which is in a form of t. So if we substitute t with anything 1, 0, 2, 5, we will get multiple values. So that's it. So
Correct. But
it
the
is not
thing
wrong.
is,
That's what I want to say, right, ma'am?
that is fine. But the thing is, we have to understand the concept of pivot. Pivot, right? Pivot is corresponding to the columns which have leading entries.
Okay.
Okay.
Yeah.
So just because see, whatever we are doing, we have to be very, see this equation. The solution is okay, but the thing is, we have to link some logic. Why? See, if you have to do some implementation, you write a program. Okay, so you cannot. So you will see which columns are pivot columns, and corresponding to those columns, you will say, okay, these are the pivot variables. For example, column 1 contains the leading entry of row 1. This is pivot. Column 2 contains the now this leading entry. It contains the leading entry of row 2. This is the first. So this is the pivot element, pivot column, and now the third column is the free column, or you say so. That's why you are saying it this as a free variable. Otherwise, there is nothing wrong in the calculation. But we have to be particular which word, which see, this is fine. This if you substitute these values in the equations, they're satisfied. They're satisfied. But we have to follow some, some what do you say, some scientific approach.
Got it, got it. That's why it is better we take x3 equal to t. That's what you are saying?
Yes, because x3 is a free variable. Because x3 is corresponding to third column, which is not pivot column. So this is correspond to x3, this is correspond to x1, this is correspond to x2. X1, X2, X3. So treat X3 as your free variable. So just from these equations, so you'll have X1 plus, just a second, huh? So this is your X3. X3, X2, X1. So X1 plus X2 plus X3 is equal to 3. Then minus 2X1 plus X2 is equal to minus 1. Now I'll write that. So X1 plus X2 plus X3 is equal to, what was it? It was 1, I guess. Sorry,
Yes,
3.
yes.
3.
Then minus 2x2 plus minus 2x2 plus x3 is equal to minus 1. Okay, so you say, okay, let's put x3 as a free variable. So free variable means give any value. Let it be t. T can take 1, 2, 3, whatever. Okay, from this x3, you substitute x3 as t. So what you get, x2 will be minus 1. Oh, sorry. Just a second. What is x2 going to be? So x2 will be, bring x3 on the other side. So minus 2 x2 is equal to minus 1 x3. So x2 will be what? 1 plus x3 divided by 2, which is same as this. Okay,
Exactly.
x3 is t. So x2 is 1 plus t by 2. Okay. Now substitute x2 value as 1 plus t by 2 in this first equation. And x3 as t. Okay, so what will you get? X1 plus, you can also do with me. Okay, so what will you get? X1 as 3 minus what will you get? I'm bad at equations. 3, okay, this is 3 minus 1 by 2. So kitna ho jayega? It will be 5 by 2. 5 by 2 minus 3 by 2 t3. T. ये हो गया. Now if you give, so t is your x3. Okay, so now you fix t. Give some value to t. T is 1. So x1 will be what? 5 minus 3 by 2. So it will be 1. And x2 will be 1 plus 1, 2. x2 will also be 1. If you change the t value, x3 value you change. Say t is equal to 3. So x2 will be what? If x3 is t, suppose it is 3. So x2 will be what? 1 plus 4 by 1 plus 3 by 2. So x2 will be 2. And what will be x1? X1 will be some value. So the thing is, as you are changing x3, you are changing x1, x2. So that's why you are saying infinite solution. That's why you are saying infinite solution. Now, why you got infinite solution? The reason is rank of A is equal to
कार्ड
huh?
कार्ड मेरे पास
What?
नहीं है ये मेरा है जाओ तुम घूमो
Guys, can you
So
please
why
go
You
on
you
can
got
mute?
mute, ma'am, you can mute everyone until you cover
so
main topic.
guys, if you do, because otherwise, if I will want to speak, then how will I listen? N is the number of variables. Then you will have infinite. Please note in your notebooks.
Ma'am, I just
Ma'am, I
have a
have a
question.
question.
So,
Oh, sorry.
yeah,
Ma'am, we
sorry.
have a.
Even if we,
Okay,
sorry.
please. Sorry.
Even if we change the like problem statement, swap the equations, ma'am, when we try to make it to the matrix, even if we swap those equations, we arrive at the same solution, right? And I just want to know the first row, it has to be always a non-zero, the leading element, right?
Yeah, first has to be non-zero. Yes.
Yeah,
Okay.
what if there is a
So
x2
if
plus
even
x3?
if you
Yeah.
even if you swap the equations, like you still have the infinite solution. Okay.
Ma'am, I have a question. Like we have a different methods also, right, to find the solution for this linear equation. So, do we need to practice these things, or like is just like to, because with a simple, elimination method also we can get the results, right? Like whether the
Yeah,
equation.
you can eliminate also. That's not the problem. But I want to link all the concepts of like rank to finding the solution. And
Okay,
rank,
it means.
how will you get it? Using the REF only. Now REF is the shortest
Right.
method.
Yeah.
So I want to tell you all those concepts. Pivot variables. So here the pivot variables are x1 and x2 only, because they are correspond to column 1 and column 2. Why they are called pivot? Because they contain the leading entries. Column 1 contains the leading entry of row 1, column 2 contains the leading entry of row 2. That's why they are called pivot variables, x1 and x2. And they are expressed in x1 and x2. The pivot variables are expressed in terms of the free variable, which is x3. Okay? So here
Okay, it
in
makes
this
sense.
case, y infinite solution rank of A is equal to
Hey, we lost the connection or what?
No, we can hear.
Ma'am?
No.
Ma'am's voice is not audible.
Yeah. Yeah, now
Yeah.
we can.
Now it's audible.
oh sorry, just a second, huh?
Yeah, we lost you for like 10 seconds. Yeah.
10 seconds. Okay, I thought some problem with the network connection.
Yeah.
Okay. So can we move ahead now? Let's do it one more problem.
Ma'am, one question here. Can you just go back? So only in case of one free variable, we are having this infinite solution, or like, okay, if we will be having uh, uh, is that possibility, like, okay, we can have more than one free variable in
Yes, you can have,
other case?
suppose in this case, I'm saying suppose if you have rank of A, now you will tell me if rank of A is equal to rank of augmented matrix, suppose it is 1. Suppose, okay.
Yeah.
And it is less than 3. Can you tell me in that case how many free variables will be there?
Two. So yeah, two free variables will be there.
Correct. Two free variables in that case. You can have one free variable, two free variable also. Okay. Can I go ahead?
Yeah, so that will also have an infinite solution, right?
Yes.
Okay.
Definitely.
Yeah, thanks. Yeah, please go ahead, ma'am.
Don't say thanks.
Sorry.
My duty. Okay, now let's go to this problem. Now you will guide me how to do. Okay. Now so first step is, what is step 1?
Form a matrix.
Form augmented matrix.
Okay, I formed. Now what is the next step? Tell me. Now you will teach me.
Convert it into REF.
Huh?
Yeah, getting
Okay,
this
convert it
into
to
REF
REF.
form.
Okay, fine.
REF.
What is the first step?
R2 plus 2 of R1.
Interchange.
Yeah.
Eliminate the no.
Ma'am, I have one question.
R2 minus 2 R1.
Ma'am,
R3 to
here
R1.
there are
Interchange.
5
R2 minus-
variables, but only 4 equations. Why?
There are 4 equations now. 1, 2, 3, 4.
But number of variables are 5, right? So ideally for 5 variables, we should have 5 equations.
No.
Isn't required,
5
right?
variables
Then
are
definitely
there
it's
because
not.
there are 5 columns. X1, X2, X3. Number of equations can be any. So you have 5 variables and 4 equations. 1, 2, 3, 4, 5. Okay, this is possible.
But in our linear system of linear equations, if there are 3 variables, we need at least 3 equations to solve them, right?
I mean, like in the first guess only, we can say this doesn't have a unique solutions, right? Because anyway, it is
You
not
can
good.
say yes, correct. In this case, you cannot have unique solutions because number of equations is less than the number of variables. I'll tell you, we'll not discuss right now here. We'll conclude it. Okay. But right now, just see this number of variables are more and number of equations is less.
Exactly.
So 5 variables, you have 4 equations. Okay. Now we will again do the same thing. Okay.
Okay, ma'am.
You will have.
Proceed. Yes. Proceed.
I'll tell you why this will not have unique solution, why it will have infinite also. That we also will derive. Okay. Now, as you said, swap rows, you suggested now. This was a matrix. Now let's say swap, because this is one easy to work with. right? So let's swap this and this. Is it okay?
Yes,
Swap
ma'am.
this row with this. I've done that. That's it. Okay, now let's play. So this will be equal to, tell me, R2 is R2. Now what is the next step? You have to convert these entries to 0.
0.
So what should I do? R2 is R2 minus 4R1.
4R1.
R3 is
4 of R1.
R3 minus, oh sorry, plus
4 of
2
R1.
R1.
Plus 2 R1.
2 of R1.
then R2, oh R4 is R4 minus
R1.
So let's see what we get. Okay, this is the logic. This we have already done. We got this. Okay. Now there is no leading entry of in this column. Okay, so you can consider this as free variable. Free x2 is a free variable. You can conclude it now because here you got 0 by row elementary operation. Okay. Now next target is, what is the next target? Now see what is the leading entry. Leading entry of row 2 is this. So that means convert all the entries below this to 0. Now this is already 0. Now you have to convert this also to 0. What row operations you'll apply? You say
R4 minus R2.
R4 minus R1.
this may not be okay.
R4 minus R2.
We'll do a row
R4
exchange.
minus.
Or R4 plus R1.
We need to do a row exchange.
No, don't play with R1. Now if you play with R1, R4 is R4 plus 1. So R4 plus R1. So what do you get here? R4 is this, R1 is this. So 0 plus 1. Here you should not get any non-zero values now. That's why
R4
you
minus
have
R2.
to make use of this R2 only.
R4 minus
What do
R2.
you get? R4 minus R2. What do you get here? Minus 1 minus 1. Okay, 0. Minus 2 plus 1 minus 1. Then
No, ma'am, minus 3.
3 minus 3, 6. 6.
6. Then
Yeah.
A minus 2. A minus 2, right?
Yes.
Right or not?
Yes.
Yes.
Now you have to, now see, this is the leading entry now of row 3. You have to convert this entry to 0 because this is present in column 3, right? To convert all the entry below this leading entry to 0. So what operation you will say? You will say, okay, R3 is
R4.
3R1. Oh, sorry. This is minus. What did you get here? Minus 1?
That will be minus 3.
Yes,
Minus
ma'am.
3
Instead
you
of
get.
minus 1, it should be minus 3.
Acha, theek hai. Thank you. Thanks. Otherwise, I would have made mistake. So now what operation you will apply? So minus 3, minus 3. So what should you apply now?
R4 minus
R4
R3.
is,
R4 minus R3.
this goes to 0. This goes to 0. 6 minus 6, 0. Now A minus 2 minus 3. So this will become A plus 1, right? A plus 1, right or not?
Yes.
Left hand side is all
Yes.
0. This is not, this is your final.
Yes, ma'am.
Now tell me. Now you will guide me, okay? Now in what situation, for what value of A, this is going to be inconsistent?
Zero. Minus 1.
Yeah, A is equal to 0 means
You are
A is
saying
equal to
0.
minus.
Any-
A is equal to minus 1.
Anything which is not equal to
Minus
minus
1,
1.
yeah.
Non equal to minus 1.
Okay.
Yeah.
So very good, very good. You are saying if A is not equal to minus 1, then you'll have inconsistent solution. That's what, because if A is not equal to minus 1, so you are saying A is 0. If A is 0, it's going to be 1. If A is say 1, it is going to be 2. So if you give any value to A other than minus 1, so it is going to be inconsistent. Why? Because this is non-zero and here you are getting 0. So that means 0 left hand side, 0x1 plus 0x2 plus 0x3 plus 0x4 plus 0x5 is equal to some. If suppose you give a value as 0, so you get 1. So this is inconsistent now.
Correct.
So for any value of a which is not equal to -1, you will get inconsistent solution. Okay. Okay, because here it is non-zero, here it is non-zero, but here it is 0. So here you will say, okay, rank of A is equal to, what is the rank of A? Only 3 non-zero rows.
3.
But rank of augmented matrix is 4.
Right.
So they are not equal. So you'll say that's why inconsistent solution. Okay, but this will happen only when you say A is not equal to -1. But suppose if A is equal to -1. Okay. Now I should ask you. Okay, tell me in which situation it will have consistent solution. Tell me.
A is equal to -1.
A is equal to -1.
If you substitute A is equal to -1, this will go down to 0. Okay.
Correct.
Now important observation is what is rank of A? Rank of A is, we will consider
Rank.
this only.
Correct.
What is rank of A?
3.
3.
What is rank of augmented matrix?
2.
2.
2.
Why 2?
3.
3 only.
3.
Okay. Augmented matrix is this now. So it
Yes.
is
3.
both are equal, but less than the number of variables, which is 5. This is less than 5. This. Now, what
So-
can you conclude?
Infinite solutions.
Okay, great point. What else? How many free variables and how many pivot variables and what are the okay? First answer. First question. What? How many free variables?
Two free variable.
Two variables.
Two variables.
X2 and X3.
2.
Tell me what are the free variables?
X2 and
X4
X3.
and X5.
X4 and X5.
X2 and X5.
X4, X5.
2 and X.
I think X2 and
See,
X5 are
this
free
column,
variables.
this column does not contain any leading entry, right? Because right or not? Because -2 is a leading, it's not leading entry. Leading entry is the first non-zero entry of a row. So this cannot be a pivot variable. What about this? Can it be? This is pivot variable because this contains the leading entry of row 2. Leading entry is the first non-zero entry. So this is a pivot column. What about this? This is because this column contains a leading entry minus the leading entry of row 3. Okay. So this is again a pivot column. What about this column? This does not contain leading entry of any row. So you said it right. X2 and X5 are free variables. I hope you got it. You understood?
Just explain this one once again. X2 and X5. X2 we got. X5. Why not X3, ma'am? Why not X3?
X3 is corresponding to this column now. And this column, see what is the first non, okay, this contains the leading entry. What is the leading entry of row 2? -1. Because this is the first non-zero entry of row 2. And this column is X3. It contains the leading entry of row 2. So that's why it cannot be considered as free variable. If a variable contains, if a column, see X1 contains, this is corresponding to column 1. This contains the leading entry of row 1. Leading entry means first non-zero entry of row 1. So this is a pivot column or pivot variable. X1 is pivot variable. Go to row column 2, X2, corresponding to X2. Now -2 is not leading entry, right? So this is a free variable. What about this? This is correspond to X3, column 3. Column 3 is containing the leading entry of row 2. -1 is the first non-zero entry of row 2. So that's why x3 is a pivot variable. Come to row
I was
4.
thinking that below -1 there is a 0. So x3's pivot entry should that 0 now after below -1 that 0 is there.
Yeah, so that's why it's a pivot, no? Leading entry, no? Understand?
Madam, can we have a rule saying that rank of A is equal to rank of augmented matrix, but the rank is less than n, which means the number of columns in the matrix, right? If it is less than n, then we can say that it is infinite solution.
Correct.
Right. Okay.
So this is your free variable. And what else I said?
X5.
And x. Now you agree why x2 and x5 are free variables? Because they do not contain leading entry of any row. Okay? Does this column contain any leading entry of any row? One is not leading entry of row 1 because this one is the leading entry. This is not a leading entry because this is the leading entry of row 2. 6 is again a not leading entry because -3 is the leading entry of row 3. Now 0 cannot be leading entry. Okay? So that's why x2 and x5 are free variables. I think we have written it. Okay, you can note it down in your notebook. Is it okay now?
Yes, ma'am. Yes.
Yes, ma'am.
Okay, now this slide just summarizes what we have said. Cannot be solved in consistent solution when A is not equal to -1. The last consists the equation, the system of equation is consistent only when A is equal to -1, when rank of coefficient matrix, that is rank of A is same as the rank of augment. This we have seen. So the variables corresponding to non-pivot elements are called as free variables. Okay, this we have talked about. And the variables correspond to pivot columns. Pivot columns means the columns containing the leading end. Okay. So if the leading end, in the REF, if you say if any column contains the leading entry of any row, then it is called pivot column, and that is the variable associated with the pivot variable. Please make a note of it. X2 and X5 are free variables, and you will say, okay, X1, X3, and X4. They are the pivot variables because they are corresponding to pivot column. This is pivot column. This is pivot column because it contains the leading entry of row 2. This contains the leading entry of row 1. And this contains the leading entry of row 3. So X1, X3, and X4. Okay. Okay, you have solution. Great. I told you, I thought we don't have solution. Okay, so X2 and X5 are free variables. Now just substitute X2 and X5 values and go start from the downwards, like the below equation. Start from the last equation. X5 is free variable. So X4 will be what? X4, you give X5 as T, 1 plus 2T. X4 is 1 plus 2T. See, here X4 is 1 plus 2T. Okay? Take X5 as T and X2 as S. X2 is also free variable. Now we have written here. X2 is also free. So now you have solved for X4. Now go back. You are doing backward substitution. Not back. So go up now. Substitute X4 as 1 plus 2T, X5 as T. You will get value of X3. So what will be the value of X3? X3 is equal to this minus 3T plus, you can just find out what is it. हाँ अच्छा यहीं से करते हैं. Okay, we have got this. So x4 will be what? 1. You just have to go backwards. Start from the bottom. So x4 is 1 plus 2x5. 1 plus 2t, because x5 is free variable. You are saying, okay, give it some name t. Okay. Now now go to this equation. Substitute x4 as 1 plus 2t. So x3 will be what? Minus 1 minus 2t plus 3x5. x5 is t minus 2. Okay. So make these convert, like put them in the right hand side. So x3 will be what? Minus 2 minus 1. So it is going to be minus 1. dt minus 2t is t. So minus 1 minus t. So that's why you get x3 as this. Now substitute all these x3 you have got, x4 you have got, and x5 is already t. Substitute it here. So what you get? X1 minus x2 is free variable. So you are giving it name as s plus x3. x3 is minus 1 minus t minus x4. Minus x4 is minus 1 minus 2t plus x5. x5 is t is equal to 0. Now what is x1? x1 is 2s 2s plus minus 1 minus, okay, plus 2 plus 2t minus t. Okay, minus 2t, this gets cancelled, so you will have plus 2. You are done. Are you
What
people
is,
there?
yeah, what is the
Yes,
whole point
ma'am.
of
Yes,
t
ma'am.
in the solution we have read?
You're just doing backward substitution. Why you are calling it backward? First, you solve for, see, you start from the bottommost. Bottommost will, like it's this. This is 0. Because a is minus 1. Then you go to this equation. Solve for x4. Now, substitute the value of x4 here in terms of what is x4? 1 plus 2t. Substitute it here. x5 as t. You will get value of x3. Okay. Now substitute. Okay. Here you have got value of x4 from this equation. Then substitute value of x4 as 1 plus 2t here. This is already t. So you will get x3 also. And now in this equation, substitute x3, substitute x4, substitute x5, and x2 as s. S is because free variable. Now this is your system of equation. As you change s, s is 1, t is 1, you will get one solution. S is 1, t is 2. This will give you another solution. So that's why this is infinite. Is it okay? Can I move ahead?
Ma'am, what is the significance of capital T here?
Capital T is a transpose, now. Actually,
Oh,
what is this?
okay. Yeah,
This is
sorry.
equal because row becomes column. So it is 2 plus 2s plus 2. S, then minus 1, then 1 plus 2t, then t. x1, x2, x3, x4, x5. This is transpose. Okay. Can I go ahead if you permit?
Yes, ma'am.
Ma'am, can you tell us about the symbols in the last statement? Inverted A is free variables and this E and R sign.
E and R? Just a second. Huh?
I
send that.
Yeah, for all t and s belongs to real number.
Acha, okay. Got it. So it
And
says
then
for
we'll just have to write the solution like a equation, and we don't have to substitute any number to s and t, right?
yeah. And this means for every T and S. That means whatever T and S. This is valid for all values of T and all values. This means for all. For all. As long as T and S they are real numbers. So T and S they can take any value. So it means for every T and S. This is for all. For all TS in R. Because if T and S can take any value, any real number. So that's why you are saying an infinite solution.
But madam, can we apply that rule and we can already find, right, whether it is an infinite solution or not? Should we really go this far and then find, or just based on the rule we can conclude?
You can conclude whether it will have infinite solution, but people may ask, now, okay, give me solution. Then you have to find the solution. You have to solve for it.
Okay. Okay, we have to solve and conclude. Okay.
Ma'am, why do we have the transpose there for the solution?
Transpose, because here you are saying you need not have transpose also, because what you are saying is you are saying the solution is the form of a column x1 x2. This you are saying, okay, solution is this, because it's a column now, because ax is equal to b. What is it? A x1 x2 x3 x4 x5. This is the column, but this is a row. So that's why you are saying transpose. If you take a transpose of a row, you'll get column only now.
Okay, okay, got it.
Okay.
Ma'am, can you please tell me that what you told for the E and R? That all TS after that?
For all TSN, this symbol you are asking.
Yeah, symbol that all TS after that. What is that? E and
Okay,
E.
okay, I got your point. So this is for all TS, means for every T S in R. This means belong. This is belong symbol. For every TS belonging to R, or you can say TS in R. That means this solution is valid as long as T and S are in R. R means real number.
Real number. Yeah.
Okay, got it.
Ma'am, do we also have to mention this belongs to thing when we solve it in a paper or something, or we can just end it with the equation values?
So people will ask, no, what is S and T? Where are they coming from? So you have to write.
Okay.
You have to write it up, because people, if you just stop it here, suppose. Okay, you don't write here. Okay, then people may ask you, what is S, what is T? So you have to write. Okay, if you don't want to write this complicated thing, just write where S and T are real numbers. That's it. That's it. If you don't want to write this belong all, okay?
No, that is okay, ma'am. That is okay.
Okay.
Ma'am, so just the three statements, can you repeat once again, which you told to note down? So if augment,
Sure.
So then we will just write it down.
Okay.
When
Maintain
it is
one notebook
consistent.
for math. Can you see the screen? So
Yes,
this
ma'am.
slide summarizes everything. System is inconsistent if the rank of coefficient matrix is A. Inconsistent means you can just write down this. Less than, you can say just not, it has to be, it cannot be greater than indefinitely. So if you say rank of A not equal to rank of augmented matrix, or you can say less than, because it cannot be greater than, because this is bigger matrix, right? So you can say rank of A, if it is less than rank of augmented matrix, then inconsistent. You can write down. Okay. Next, system.
So the original matrix A is the coefficient matrix.
Yes, A is the coefficient matrix where you have the coefficients, A11, A12. Okay, next, system is consistent if the rank of coefficient is same as rank of augmented.
Yeah, is equal to n.
No, not, we are not talking about n right now. Whether it is n or less than n, it will be consistent. Okay. Now, first consistent system, if there are no free variables. No free variables means, what do you mean by that? This is equal
Consistent.
This one
to
is unique.
N.
n, number of
This is
variables.
unique. Yeah.
Where n is the number of variables. For consistent system, if there are free variables, in that case you'll have this.
No
Then you have
solution.
infinite.
Okay.
Yeah, no solution
This is unique.
yeah. No solution is rank of A is less than rank of augmented matrix.
Correct. You can just note down.
Yeah.
In your
Ma'am,
notebook.
you will share this PPT, right?
Definitely.
Because what you shared before does not have all these things. So therefore.
Yeah, because that was this is the updated one. Okay.
Yeah. So you will
All
put it
right.
in Taxila. You will put this in Taxila, correct?
No, not Taxila. Teams.
Only in Teams. Okay.
Are you people there now? I think I got signal that I'm disconnected. Hello.
No, ma'am.
Hello.
You're audible.
No.
Ma'am.
Yeah, it was my issue only. Sorry.
Okay, now you go to some new concept. But no, it's not that new because it's still related to REF. Now we have to understand what is a vector. We already taught.
Magnitude and direction. That's what we said. More than one variable.
Suppose house is there. You want to predict the price of a house. So you'll represent house 1 as, suppose, number of rooms, area of house, then proximity to airport, how far it is from airport, because that is also one of the feature people consider while buying the house. Proximity to airport, like even price also determines that. What is the next feature you will take? Okay, whether lift is there or not. The next feature could be
Ventilation.
no, that is subjective feature. Subjective. Someone will say okay, ventilate. It is ventilated. Someone will say no, it is not. Okay,
How
what is
close
the
is the
next feature?
hospital or the schools?
Proximity to hospital.
Airport.
Okay, so house 1. Suppose you visit one house, then you visit second house, then you visit third house. So house 1 is number of rooms is suppose 4. Area of house is say 4,000 unit. I'm just you can assume proximity to airport 3 kilometers. Lift is there or not? Yes, 1 or 0. I'm binary representing. Lift is there, okay, 1, otherwise 0. Otherwise, okay, proximity to hospital. Suppose yes. Okay, house 2 is there. So this is a vector of value. So this is a feature you say. In machine learning, we start the features only. Feature vector. So this is a vector. And how many values it is having? 1, 2, 3, 4, 5. Similarly, you can have for house 2, house 3, so on. So everything boils down to vector only. All right. So a point in R1. So you have a real line now, mine 0, 1, 2, 3, so on. This is the R. Okay. This is -1, -2. This is just one dimension. Now, if you go to R2, what is R2? XY plane. You know na XY plane. So any point you have XY, two values. So it belongs to R2 plane. Now, if you have R3, when Rn is 3, so you have three-dimensional X, Y, Z. So any point, say 1, 2, or 4. So this is a point in R3. It belongs to R3. Okay. Now, what are the operations you can do here? So you can just add two vectors, Suppose I add 1, 4, 7 plus 2, 3, 9. 1 plus 2 is 3, 3 plus 4 is 7, 9 plus 7 is 16. You can add two vectors, provided they are of same length. For example, this is vector of length 3. Not, I should not call it length, I should say number of elements. So this is having 3, this is having 3. So if I just add this 1, 4, 7 plus, you tell me, can you add this? Can you add this?
No.
No,
No.
cannot.
Because this is 4 having 4 components, this is having just 3 components. You cannot add. Okay. So both should have the same components. Same number 1, 2. Okay. Now let's talk about multiplication by a scalar. For example, if my vector is this 1, 2 or 1, 2, if I multiply with a scalar, this is allowed. This is multiplication by scalar is any real number. Okay. So you get 2, 4. That means you are stretching the vector. Earlier it was 1, 2. Now it goes to 2, 4. You have stretched by multiplying. This is stretching. Okay. So this slide just talks about the vector concept. What is it? So it is represented by n tuple, n components. Okay. And then it just says that you can add two vectors, x1 plus y1, x2 plus y2, and so on, xn plus yn. And you can do multiplication by scalar. Okay. Moving forward, now what is
What
a
does
linear?
r to the power n means? What does r to the power n?
This is a space. For example, I told you now, this like you have R2 space. What is R2 space? If n is 2, so it becomes R2. So R2 space is XY plane. You know now XY. You have seen in
Two-dimensional.
graphs, 2-dimensional. R3 means it is 3-dimensional space. You have X, Y, and Z. So Rn is n-dimensional space. Okay.
Okay, got it. Yeah.
Okay, now let's talk about linear combination. Okay, so if you have, okay, let me talk about, say, you suppose you have m vectors, each is n-dimensional. Then what is a linear combination of these vectors? So it is C1, V1. So that is you are multiplying each vector by scalar and then you are just adding it. So this is called a linear combination of vectors. So the technical name given to it is a linear combination because you're combining these m vectors. Okay. Now example, you can take like this 2. So transpose it like this 2, 1, 3. This is the vector plus 3, 1, 0 is equal to what is it? So 2 into 1 is 2 plus 3. Now 2 into 3 is 6. 3 into 0 is 0. So it is 2 plus 3 is 5 and 6 plus 0 is 6. So this is the linear combination of the two vectors 1, 3 and 1, 0. This is transpose. So row becomes column. Okay. Now again, this is very, very important concept. You will use when you study MFML. Okay. Now what is linear independence? Linear independence is like, how do you test whether vectors are linearly independent? So it's like, if suppose you want to test V1, V2, Vm, are they linearly independent? So what do? You say, you take some C1, V1, C1 is some constant, like scalar, scalar. C1, V1 plus C2, V2 plus Cm, Vm is equal to 0. Now this is what? 0 vector. Okay. This is 0 vector, not a scalar 0, because V1, Vm, they are the vectors. Okay, they are n-dimensional vectors. So if you take linear combination, you will get a vector only now, like we have done here. Okay, sorry, just a second. So this is, you have taken the linear combination of two vectors which are in R2. So you have on the right hand side, you get a vector in R2 only. So similar is the case here. So this is, if you take the linear combination of these m vectors, you'll get a vector. This is again in Rn. Okay. Now, if you solve this equation such that if you get all Ci's to be 0, then you say V1, V2, Vm, they are linearly independent. Then only you say they are linear independent means they don't depend on each other. V1, V2, they are independent. For example, take the features. Let's talk about the features. So you say, okay, number of rooms, area of the house, proximity to the airport. Okay, these are all independent. Means number of rooms does not depend on area of the house. Area of the house does not depend on proximity to the airport, right? So suppose this is n, you say n, a, this proximity, like take it as distance to the airport. So you say, okay, this is your feature 1, C1 N1 plus C2 A N B plus C3 D is equal to 0. And here all CIs you should get at 0. Then only you say these are linearly independent features. But if I take, suppose, number of rooms, then area of the house. Next feature I take, okay, area of the house divided by the number of rooms. Now this feature, it depends on this and this also, right? So you say, okay, this is dependent, this vector, like this feature is dependent on this and this. So you'll not say, okay, this is linearly independent. Okay. Okay, now let's, now if they are linearly dependent, suppose they are linearly dependent.
Ma'am, can you go back to the previous slide once, ma'am? I have one doubt.
Yeah.
So here you are saying that if in the equation that C1 V1 plus C2 V2 plus CM Vn, all the if all the Ci are 0, then we can say that if all the Ci's are 0, then we can say that it is linearly independent.
Correct. Okay, then only you say linearly independent. But if this happens that, okay, you say at least, if you get at least one Cj which is not 0, then what will happen is Cj Vj you say is equal to minus C1. Actually it's like this, C1 V1 plus C2 V2 plus so on Cm Vm is equal to 0. Now you want to test whether they are linearly independent or not. Suppose you get one Cj as non-zero. So keep that Cj Vj here and bring rest on the other side. So you'll say minus C1 V1 minus C2 V2 and so on minus Cm Vm. Now this Cj is not 0. So you can divide it the whole equation. So minus C1 Cj V1 minus C2 divided by Cj V2 and so on minus Cm Cj Vm. Okay, now Cj is not 0, so you can divide. So you can see Vj is dependent on V1. Vj is dependent on, it is dependent on all V1, V2 till Vn. So you say the set V1, V2, Vn is a linearly dependent set. I'll give you one example. Okay, so in real world application, we don't want to work with linear dependent features. We want all the features to be linearly independent, because if you have dependent features, so they'll carry redundancy. Okay, because if you have say 1,000 features and some of the features are dependent on other features, like they're derived. For example, if you have feature like age, date of the birth of a person, now they see age is derived from date of birth only, na? So this is linearly dependent on this. So you can avoid this. So we have to work with linearly independent features only. Okay. Now let's see whether these features are linearly dependent or not. So if you see this, so when you take the linear combination of these two, 2 into 1, 3 plus 3 into this is equal to 5, 6. So that means this vector, okay, it is dependent on, so this is V1, V2, V3. So V3 is dependent on V1 and V2. So together, if you see, this set is a linearly dependent set, because here you get C1, V1 plus C2, V2. This is minus, you bring this here. So you get minus C3, V3. So it's like this, C1, V1 plus C2, V2, or you can say plus C3, V3 is equal to 0. V1 is this, V2 is this, V3 is this. So now C3s are, you have at least one CI, which is not 0. So you that's why you say, okay, this is linearly dependent set. Okay. Now, if you want to find whether this is linearly dependent or not, what do you do?
Ma'am, can you repeat this once again, please?
Okay, this one.
That part, yeah.
Okay, okay. So, so you have this. So here you are being shown that linear combination of these three vectors. You are just shown that. Okay, 2 into 1, 3. This C1, this suppose this is V1,
Ma'am,
V2,
in the below example 2, it is taking like A and B. So A and B are 0, so it is telling it is linearly independent. So can you show like that in example 1, taking A, B, C?
Good point. Good. That will handle your doubt. Good. Okay. So if you just ignore this, so you want to prove whether this is linearly independent or dependent. So you start with this C1 into this is V1 plus C1 V1 plus C2 V2 plus C3 V3 equals to 0. Okay. So C1 is 1, 3. V1 is this, right? Plus C2 is 1, 0. Plus C3 is 5, 6. Okay, is it okay? Now 0 means 0 vector you have to consider, because this is a vector of having two components. Okay, now let's go ahead. Now tell me, what should I do? You will guide me now. Yes.
Multiply with C and add.
C1 plus C2 plus
Minus
C3.
C2.
C1 plus C2 plus
3 C1 plus 0 C2 plus 6 C3.
Not getting
What happened?
C1 plus C2 5 1.
So, ma'am, how are we considering this is, I mean, 1, 3 as C1, V1 and 1, 0 as C2, V2? I mean, it can be anything, right?
Because we have to consider like this now. C1 vector is this V1, this is V2, this is V3. If you want to check whether the vectors are linearly independent or not, V1, V2, V3, so it says you start with this now, where CIs are the scalars. They are belonging to real numbers. They are real numbers. So you have to start with this. And if you prove that all CIs are 0, then you say linearly independent, otherwise not. Okay? Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. So that's why I started. So this is your V1, this is your V2, V1, V2, V3. Okay. Then I said, let the starting point is this only. C1, V1, I want to test whether they are independent or dependent. Now I started with C1, V1 plus C2, V2 plus C3, V3 is equal to 0. Now if I prove all CIs are 0, all like C1, C2, C3, suppose I get them all zeros, then I'm done. I say, okay, these are linearly independent. Now let's see. From this, again, this reduces to the system of linear equations. 3C1 plus 2C3 is equal to, now this is equal to, okay, tell me, this reduces to this now, C1, C2, C3, right?
Yes.
Write it as system of equations now, 1, 1, 5. Then what do you write here?
3, 0, 6.
306.
3,
Zero, zero, zero.
no, 0 and 0. True equations now. Okay, tell me. What should I do? Do elementary operations.
REF.
R2 equals R2 minus
R2
3R1.
minus 3R1.
R2 minus 3R1.
Yes.
0 minus 3. 6 minus 15. What do you get? Minus
9.
11.
9.
Minus 9.
Minus 9. Are you sure? I'm
Yes,
relying
ma'am.
on you
Yeah, ma'am, it's correct. 6
for
minus 15.
calculations. Oh, this is second. Oh, okay. 115. Now this is in REF form now.
Correct.
C1, C2, C3 you get at 0. 0, 0, 0 because sorry 0 and 0. 2 zeros. Because it is
0.
R2 equations now. Okay. Now what do you get?
One
Minus
free
3
variable.
minus 3 C2 plus 9 minus 9 C3 is equal to 0. Okay, tell me which is your free variable?
C3.
Correct. C3 is the free variable. Let us give it value as say minus 3 C2 is 9 C3, right? C3 is T. Keep it as T. Now C3 is T. It will definitely have infinite solution. T can be 1. Like, so C3 can be 1. C3 can be 2. So you have got at least one CI which is non-zero. C3 is not zero now. Because it is infinite solution.
Correct.
So
Yeah.
that are you getting? That's why it is linearly dependent. See, you started with this now C1 13 plus C2 10 plus C3 56 is equal to 0 0. So you saw that okay, C3 because this is called the free variable. You saw C3 is a free variable.
Yes.
And when you have free variable, you'll have infinite many solutions. And in that case, you can consider C3 to be non-zero now. You can have that. And once you get, because what is the definition of linearly dependent set? Let me just put it side.
All of CI should be 0.
No, all CI, at least one CI should be 0, non-zero. If you get at least one CI, one CJ to be non-zero, you are done. You are done in proving that, okay, the vectors are linearly dependent. There exists at least one CJ. At least one, but just one you need to prove that the vectors are linearly dependent. So you've got one C3 now. So that's why they're linearly dependent. Now let's take one more example. And C1, C2 can take these values also. C1 is 1, C1 is 2, C2 is 3, C3 is minus 1. So this is also, So you've got all of them to be non-zero. So that's why they are linearly dependent. Okay, this is one type, one solution. Though we have found out there are infinite solutions for C1, C2, C3. So take one solution as okay, C3 is non-zero. So C and then there is no need to find C1, C2. Okay,
Ma'am,
now let's do.
so just one thing. So in the first example, just we need to find values like in that just 2 and 3, that coefficients 2 and 3, it was
Need
found
not
that
be. It need not be 2 and 3. It can be anything, but whatever you value, you give. Okay. This equation should be maintained. Like you should be like I told you, not that you have obtained. Like if you solve, see these values will not be given to you. Will be given. Okay. Just test whether these systems are these vectors are independent, linearly independent or not. So what do? You just say C1 V1 V1 is this plus C2 V2 plus C3 V3 equals to 0, and then try. Then you'll get a system of equations as we have done here, and then do REF, and then you are good to go. You can find whether the ranks are equal or augmented matrix, and then you can just see whether this is like it will have infinite solution or not. Okay. And then if it is infinite solution, or if it, even if it is unique solution, then you can say, okay, they are linearly dependent set. Is it okay? See, the target is. Okay, let me take one more example. Second example, let's take. Okay, we have to find this the set of two vectors is linearly independent or not. So you'll take, okay, let C1 V1 plus C2 V2 equals to 0. This transpose means vector. So C1 1 3 plus C2 1 0 is equal to 0 0. Now you say what you get, system of linear equations C1 plus C2 equals to 0, 3C1 equals to 0. 3C1 plus 0. Now C1 is 0. Substitute C1 0 here, so you'll get C2 is 0. Actually, it's a unique solution, but both are 0. And when both are 0, see, both are 0. This is 0, this is 0. So that means they are linearly independent. That's it.
So,
Okay.
so if free variables came, then that will be linearly dependent all.
Yeah, infinite.
If three variables come, then you are saying linear. Need not be. Because if you have, say, see, this is two-dimensional. If you have three-dimensional.
No, not three. Free.
Free variables.
Okay, you are saying free variables. Yes, if you have free variables, then definitely it is going to be linearly dependent set. So you saw in this set, like you saw the system of equation and you said that, okay, C3 was free variables. As soon as you get free variables, you will come to know, okay, there are infinite solutions. So you can give value to some non-zero value to C3, right? So you will immediately say, okay, this is linearly dependent set. Okay. Okay, let's do one more problem.
Ma'am, can you go back to the previous slide?
Yes, yes.
Good. So in the example 2, where we have two matrix 1 3 and 1 0, two vectors, there you are I mean in the second step you are assigning to a 0 vector, but in the first example, why are we doing it? I mean C1 B1 and we are equating it to 5 6. Why not C1 C2 plus C3 equal to 0? Didn't get that.
You ignore this. Ignore this. Actually, this is just trying to show that this vector is dependent on these two vectors. Ultimately, how did it arrive? It arrived starting from this point only. This is the starting point only. This is just giving you example of C1, C2, C3 for which this link for which it is showing the dependency. C1, C2, this is Actually, should be this. Is this okay? This just write that okay. If you
Okay.
take C1 is 2, C2 is 3, and C3 is -1. So you've got at least one value of Ci which is non-zero. This is enough to show that okay, this is linearly dependent set. Is it okay now? This is actually here it is given, and here
2,
it is
3.
trying to show. Here
I mean, how are you writing 2, 1? I mean, 2 of 1, 3, and 3 of 1, 0. I'm sorry, I'm not getting this vector. And
2 into 1 is what? 2. 2 into 3 is 6. This is scalar multiplication. Plus
yeah, but
3,
2, where are you getting it from?
2 plus 3 is 5 now, and 6 plus 0
No.
is 6.
Achha, based on that 5, 6.
We got
calc.
that from that free variable t, right? So t you put as -1, you get 2.
2 and 3, ma'am. That multiplication I understood. 2 into 1 is 2, and then 2 into 3 is
So you're
6.
getting,
That
you're putting C3 as -1. How you get this value? You can put C3 as -1 and then derive C2 and C1.
Yeah,
From
Okay.
if I can just my understanding that if we are given like these three vectors, then if we can
No.
find any equation like summation of these two vectors equal to the third vector, like twice of vector 1 plus 2 times vector 1 plus 3 times vector 1 equal to, if we can find that in example, like in example 1, we can straight away say that these are dependable, right?
Correct.
Yeah. So I think
in the second example, we are deducing that A equal to 0, B equal to 0 using REF. But if we can straight away say that yes, 2 times vector 1 plus 3 times vector 2, we are getting the third vector. We can find a combination between the vectors. Then we can say that these are dependent vectors. That's all.
Yes, that's all.
Yeah. So the simple
somewhere-
statement is for the given, let's say, set of inputs, we have to form the augmented matrix. On the right hand side, we will say all 0 because that's what we want to prove. And we will calculate the REF and solve for C1, C2, C3.
Yes, great. Now we have to analyze this. Let's do. Now this is just pictorial description.
One question I
vector is
got.
this.
Somewhere
one
the
vector.
determinant is also related to linear and linear dependent, independent.
Come again. You are talking about determinant.
Yeah, determinant value will be also matter.
I'll come to it. Just one second.
Sure.
Madam, can we logically close because we are already nearing our time?
Oh, we are saying that time flies. Like, okay, let's talk about this rank and linear. So you talk
Ma'am,
about
you go back to
determinant.
the previous slide. You were showing something in that in the previous slide. Yeah, please show that.
Okay. So this is vector 1, 2. Okay, 1, 2 you have plotted in 2D. Okay. 5, 1 vector is this. This is 5, 1 point. Now if you add these two, 1 plus 5 is 6. 2 plus 1 is 3. So this set of vectors form a linearly dependent set, because here if you say C1 V1 plus C1 is 1 here, C2 V2. If you bring here, so it will be minus plus C3 V3 equal to 0. So here you have at least one Ci which is non-zero. In fact, here all Ci's are non-zero, right? So you say that this is a linearly dependent set. It's just plotting in graph. This is your V1. Sorry, just a second. This is your V1. V1.
Do we need to show it like a graph?
No, in exam. See, in real life, you will not have 2D vectors. Now, in real life, you don't have 2 feature vectors. You have n number of feature vectors, which cannot be. This is just for visualization.
Okay, okay.
Like V1, V2, when you add, you get V3.
Ma'am,
So here all
just you can modify your screen that it is coming like
It's coming split screen. Two
it is
screens are
splitted. It is splitting.
Ma'am, you have to swap.
out here.
Yeah, you have to swap the screen. Yeah.
Yeah, yeah. Now it's
Splitting to nahi. Okay. Okay, now let's go to the concept. Concept is if you have a p vectors, okay, such that each of these vectors have n components. So x1, x2, xp, p vectors, they have n components. That means this can be written as x11, x12, x1n. Okay, this is written as x21, x22, and x2n, and so on. Each have n components. Okay, then these vectors are linearly independent if matrix formed with these vectors have rank p. Okay, so you have p vectors x1, x2, xp. Okay, they are considered to be linearly independent when their rank is p. Okay, because in that case you will not have any free variables, you can say.
in previous exam in the previous concept we were getting that if less than p then it is inconsistent, right?
Inconsistent, it like, so here you're talking about, see, here you have to look at this augmented matrix only. So if the rank of A, if the rank of A is, suppose A is a matrix which contains p vectors x1, x2, xp. If the rank of this matrix is p, then you say these are linearly independent vectors x1, x2, xp. And if the rank is less than p, if the rank of A is less than p, that means some of the columns, they are linearly like, some of the columns are pivot and others are non-pivot element, right? I'll show you just so you, and then rank of all matrix is also equal to the maximum number of linearly independent column vectors. So rank of a matrix is a maximum number of.
What is a vector, ma'am? What is a? What is a?
A is a matrix consisting of the vectors.
Okay.
Okay, I'll show you all this. Let's take okay. Now suppose you have 3 vectors, x1 column vector c. Okay, let's take it v1, v2, v3. Now you have to check whether they are linearly independent or not. So first, what do? So c1 v1 plus c2 v2 plus c3 v3 equals to 0. Okay, so what you have is c1 v1 is basically this. Just a second. I'll do this, then I'll stop because I want to link this linear independence with the rank. So C1 1 2 plus C2 2 4 plus C3 3 4 equals to 0 0. Okay, then you have C1 plus 2 C2 plus 3 C3
is
2
0.
C1 plus 4 C2 plus 4 C3 equals to 0. Now, yeah. So you just collect the coefficients 1, 2, 3, 2, 4, 4. C1, C2, C3 equals to 0. Okay. Now, do the REF thing. REF, just do REF. So how do you get? So yeah, R2 is R2 minus 2R1, 1, 0. So 4 minus 2 into 2 is 0. 4 minus 3 minus 6. Am I doing it correctly? You
Right,
have to
correct.
bear with me
Yes,
for
ma'am.
my calculation.
Correct. Yes,
No,
ma'am.
it will be C1, C2 only, right? Not C3.
What are you saying?
No, because there are 3 variables, right?
3 columns.
Okay.
Three
Okay.
variables.
Okay. Okay.
3 columns. Now, point to be noted is tell me what are the pivot columns.
1
Pivot
and
columns are the ones
First
sitting in
and
the
C3.
First and
first,
C3.
first and
Third.
third, because this contains the leading entry of row 2. Now, pivot columns, important observation. Pivot columns are the linearly independent ones. Only these 2 columns are linearly independent. That means they cannot be expressed in terms of each other. But this column is a non-pivot. Non-pivot is dependent on these 2. That means it can be expressed. This is non-pivot. Non-pivot column can be expressed as a linear combination of first and third. Okay. So together they make a linearly dependent set because this is dependent on the pivot. Non-pivot column will always depend on the linear combination of the pivot columns. So that's why you'll say that these vectors, they are linearly dependent because the rank, what is the rank? Rank also you say rank is equal to, what is the rank? Rank
Rank
of
is
this
2.
matrix is number of non-zero rows 2. Number of non-zero rows is 2. And we have just concluded.
And it is less than n.
Sorry. Yeah. So we have just concluded that if the rank is less than this is the number of number of vectors. P is the number of vectors. Then they are linearly dependent. Okay.
Okay.
Yeah. Are we interested
So
in
we can
linearly independent or dependent equations?
What? Come again, please.
I mean, throughout this course, we'll be dealing with more dependent or independent
Everything boils down
equations.
to see. Yeah. See, you start with whether you talk of PCA. PCA is principal component analysis. Because there you have collection of say 10,000 feature vector of length 10,000, which is very very huge. So you have to reduce. You have to what? It is not visible.
Yes, ma'am. Visible. Visible.
So everything. So there also you need concept of PC. You have 10,000 feature vectors. So you have to transform into some space which has feature vectors which are you transform into vector of say 100 features, like 100 dimensions, where all of them are linearly independent. So that's why we are doing all these concepts.
Yeah, if they are linearly independent, we can find a unique solution. That's
No. Linearly independent means you don't have redundancy between the features. Now, like I told you.
Yeah, they are.
Means those are only important for us.
Yes, linearly independent means one feature is not dependent on other.
No, linearly dependent means it is multi-collinearity, right? One, or we say that.
Yeah, you will see. You will you learn all these terms when you do linear regression. There, these terms will come. Okay. Now let's boil down to what we want to say. So we have concluded from this if the rank of the matrix, we have got this, that if the rank of a matrix is less than the number of vectors. So here we saw the rank of the matrix is 2, which is less than the number of vectors 3. Okay, and rank is equal to the number of linearly independent columns. And number of linear independence column means number of pivot columns. I'll write here rank of A is equal to, this is general, number of linearly independent columns. Linearly independent columns are the pivot column. Number of pivot columns. You can write it down. Okay. And if the rank of A means
So
A is a collection of
the
all the
first one is
vectors.
for the independent, right? Or let's say, sorry, independent. First one.
The
The
rank
first
of
one.
this is 2. Rank is this is 2. And only 2 are the linearly independent vectors now. Oh, sorry. 2 are the only independent columns. And if this rank is less than, now comes the concept of like whether they are dependent or independent. Now, if the rank is less than the number of columns, P is the number of columns. A P is the
Okay.
number of columns.
Then what we say? It's independent. Dependent.
Yeah, dependent. Here rank of A is 2, which is less than the P. P columns we took. Right? Then you say rank, then you say the columns are linearly dependent. Here we have seen now, here we have it is written here.
Correct. If it is equal,
Here
then independent.
Yes. If the rank equals the maximum number of linearly independent. So rank there we saw it is what is the maximum number of linearly independent vectors? It is 2. Okay. Therefore, rank of A is same as rank of A transpose. Okay, which is equal to R. R is the number of linearly independent maximum number. You should say maximum number of linearly independent vectors. So consider P vectors if each of them have n components. So likewise, here are 3 vectors. Each of them they have 2 components. Okay, and if n is less than P, each vector is having 2 components. 2 is less than the number of vectors.
3.
Then vectors are linearly dependent. Okay. So we'll do one more problem. Okay, let's analyze.
Just go back to the previous slide once. Just go back to the previous slide once.
This slide.
So it means if it is not for any non-square matrix, like previously it was a like of a 2 row 3 columns. So if anything like it is not a square matrix, then we can say that like.
Yeah. Even for square matrix, if you consider, you can have square matrix also. If you have suppose square matrix, are you people there?
Yes, ma'am.
Hello.
Yes.
Yeah, we are here. We are here.
अभी तक तो है. अभी तक तो है.
But time is up.
Yeah,
We have cause to attend as the weekday.
But still, okay, I understand. Oh, okay, I'll just finish this off now.
Sure.
If it is a square matrix, then if the rank is same as, suppose this is 3. If rank is same as n, that means all the columns are, this suppose n is 3. Okay, then you say all the columns are linearly independent because all the columns in that case will be pivot columns. So in that case, the columns will be linearly independent. Okay. Pivot columns are the columns containing the pivot elements. So the pivot columns indicate that the vectors are, so pivot columns means they are linearly independent. And the non-pivot columns, I told you, they can be expressed as linear combination of pivot. Okay, let's check one more. So you will tell me, okay, these are three vectors, but they are having 4 components. So what do? You just do this C1, X1. So take them as a column of a matrix. Now find REF, find the rank. Okay, for REF you already know. Okay, I've got final REF as this. Now tell me what are the pivot columns.
3.
3, because this is the pivot column 1, pivot column 2, because pivot column 1 because it contains the leading entry of first row. This is a pivot column 2, it contains a leading entry of row 2. This This is the pivot column because it contains leading entry of row 3. And we have said that all pivot columns are linearly independent. See, they are pivot columns means they are all linearly independent. So that means the rank is here. What is the rank here then?
Rank
What
equal
is the
to
rank?
three.
Three.
Rank is equal to
Rank is
3. This
3.
is number equal to pivot columns. Pivot columns are
3.
Pivot columns are linearly independent column. Okay, is it okay?
Okay.
Yeah.
Yes, ma'am.
So I'll just summarize in one line. So rank of matrix is equal to the maximum number of linearly independent columns, which is the number of pivot columns. Okay. And
Yes.
if the rank is less than the number of pivot columns, if the rank is less than the total number of columns, then you say that it is a set of linearly dependent. Okay, we have seen now if rank is less than P here.
Yeah.
They are linearly independent if the rank is less than the P. P is the number of columns that you want to, number of vectors that you want to see whether it is dependent or not. Okay. Okay, I stop here.
Yeah. Thanks. Thanks.
Okay.
Thank you, ma'am.
Excuse me, ma'am.
Thank you.
Thank you.
Yeah, please go ahead.
Ma'am, in the quiz that you have given, right? For problem number 13, I'm kind of stuck. Would it be possible for you to share the solution?
Problem number 3, can I? Okay.
13.
13. Can you share? Okay, I'll just check. I think I have it here. 40.
Ma'am, can you please tell me where to check in Teams for your assignment?
Teams. I'll
Yeah.
just check. You asked about question 13 in quiz now?
Yes, ma'am.
For what value of k does the system have no solution? I'll just copy this in the PowerPoint.
Also, ma'am, can you please share these slides?
Yes, definitely. I'll just paste it here. Now let's do. Okay.
Thank you, ma'am. Ma'am, what is the question, ma'am?
It says you have to find the k for which this system of equations will not have any solution. Take the augmented matrix. Then apply. You did this?
Yes, ma'am.
3 minus 2 is 1, 4 minus 2 is 2.
And
2
0.
minus 2 is 0. Then 3 minus 3 is 0.
0.
5 minus 3 is 2.
K minus 3.
K minus 3. Then this is 3
0.
minus 3 0. Okay, you have no solution. No solution means, okay, we have to do one thing more.
One more thing.
1 0 0 1 1 2. Now you have to apply, you have to convert this to 0. R3 is R3 minus
2 R2.
1 0. Then K minus 3 minus 2 K minus 5.
7.
Okay. So, okay. For which it does not have any solution. That means
K minus 7, ma'am.
Oh, sorry. K minus 3 minus. Now this is, so here we're getting it 0. So here you should get it as non-zero now. K
Ma'am,
not
the
equal.
non-zero should be in actually on that side, no, ma'am, on the
No,
fourth
it is
column.
not necessary. No, it is not necessary. You have to just see if you want no solution, if you don't want any solution, if you are getting on the right hand side
K
as
should be
0.
7. K should be 7 to get no solution.
No, that would be infinite solutions.
That's correct. Correct. K is equal to 7 means
solution
infinite
is
solution.
Inconsistent. So for inconsistent, if you want to 0 here, so it should be non-zero now.
Ma'am, the non-zero should can exist on any of the column, ma'am. I thought the last one, right?
So here you have, it's like this, k minus 7z equals to 0.
Yes.
Actually, if you say, so this means where whatever is the, if k is 7,
Can we say if k is not 7, then there is no solution?
3z, no, if k is 7, the 3z is equal to 0. So z is 0 here, you cannot say this mistake here. Yeah, you're right. K should, anyways, yeah, you're right. Because here what you are saying is if this is suppose non-zero, so you are saying whatever the value, suppose k is 8. So you'll have 8z is equal to 0. So here this will derive z is equal to 0. Right?
It will become infinite
Yeah.
solutions.
Yeah,
Right?
this is no, not infinite.
No,
It
like
will
if
still
it
be,
becomes
so you should say basically k is not equal to, because if k is 7, then 0z is equal to 0. That is fine. Here what you are getting is, right hand side you are getting 0. No, we are getting,
yes, ma'am. That right side should not be 0, right? It should have been some number.
yeah. Right, we did some calculation mistake. Oh, just a second. We did calculation mistake some.
No, ma'am, a calculation mistake is not the exact. I think one of the equation given might be wrong. It is coming out to be 0 only.
Right hand side is getting as 0. Actually, k should come on the right actually.
Yeah, yeah. I mean, if it was the fourth column, then we could have told that.
Okay, just a second. Just compute the rank of A. एक बार फिर से कर लेते हैं फटाफट. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. Oh, anyways, I'll do it after the class. Okay, others have any doubt, I'll check it.
Sure, ma'am. Thank you.
Okay. What's your name? I'll just put it.
Divya.
Trivida.
Ma'am, can you share in the
Divya.
Teams chat solution and the PPT as well?
Yeah. I'll share.
And where is the assignment shared?
Just go to Takshila, na?
Okay.
I'll just stop recording.
Under course handout.
Huh?
I think it's under course handout, right? Quiz and practice assignment.
Yeah. Just go. You can see the screen. My screen is not shared.
Yeah, now you can.
Not shared. Just go to this access courses. You must have got the link for zero course. Go to your course. This is your course, right? Go to the course. Practice this linearly dependent and independent questions. I'll post it today in quiz and assignment. See, where is it? Yeah. Course content, slides. These are the base slides. Quiz 1 and practice. These are the questions. It is uploaded. Okay.
And ma'am, if we have to validate our solutions, where we can do those validations, like if we want to see the answers.
Okay, you want to see the answer. Okay, we'll post the solutions also. Maybe on Thursday.
Fine.
Okay.
Thanks, ma'am.
Okay.
Yeah, thank you.
Thank
you.
Thank you.
Ma'am,
bye-bye.
this quiz and solution are in the doc form. Actually, I thought it will be like a quiz with timer or something like that.
No, we don't